Welcome to the building blocks of the digital universe, a field guide to data representation, shapes, and formats. We will explore how data is organized into structures like tables, hierarchies, and graphs. At its most fundamental level, data consists of bits and bytes, the invisible raw material. Bits are simple zeros and ones that map to physical transistors. Their meaning changes entirely based on how the system interprets the sequence, turning them into integers, ASCII characters, or pixels. Text and time rely on global translation rules. Character encoding, like UTF-8, acts as a universal adapter, translating over 140,000 characters into bits. For dates and times, best practice is to store everything in Coordinated Universal Time, UTC, to ensure an objective, fixed moment in time. Numbers require a trade-off between precision and size. Types include integer and big integer for counts, float for scientific data, and decimal for money. A crucial warning: never use floats for financial totals, as they are approximations that can ruin your calculations. Always use decimal types for currency. Tabular data, organized in rows and columns, is powerful due to its uniformity. Each row represents an entity, and each column is an attribute. Primary and foreign keys link isolated tables, creating a network of related data that is easily sorted and filtered. Hierarchical data, such as e-commerce orders or organizational charts, is naturally structured as trees and nested objects. JSON is the common format, allowing infinite nesting. However, analytical engines often require flattening JSON into flat rows for processing. Graph data maps relationships between equals. It's used in social networks and fraud detection, answering complex questions about connections and routes that flat tables cannot. Nodes represent entities and edges represent their relationships. Time series data is where sequence is everything. It relies on temporal order to make patterns visible, such as seasonality, long-term trends, and sudden anomalies. Examples include server CPU usage, stock prices, and heart rates. Geospatial data merges the map and the address book, typically represented by points, lines, and polygons. Neither location nor context is useful alone, but Geographic Information Systems, GIS, perfectly merge the two. Media data, including images, audio, and video, are mathematical grids. Images store color intensity grids. Audio is based on sound waves sampled thousands of times per second. Video achieves massive compression by only storing the differences between consecutive frames. A modern application is an orchestration of these data shapes working together in real time. For instance, a delivery app uses tabular data for user info, time series for traffic, hierarchical JSON for orders, geospatial data for location, and graph data for routing. The schema is the blueprint and contract of data. Schema on write enforces structure immediately, resulting in clean, reliable data. Schema on write accepts raw data first, offering flexibility but often leading to messy interpretation later. Schemas are living documents, and failing to manage evolution is a top cause of data corruption. File formats serve different purposes. CSV is universally supported but easily broken. JSON is excellent for web APIs and deep hierarchies, but slow for analytics. Parquet is a columnar binary format designed for massive analytics. Avro is a row-oriented format that embeds a schema, championing Kafka streaming. The big divide is between row-oriented and columnar storage. Row-oriented formats like CSV and JSON must read every piece of data to perform calculations. Columnar formats like Parquet are 10 to 100 times faster for analytical queries because they skip irrelevant data at the hardware level. Here is a cheat sheet summarizing key takeaways. Remember that data representation is a decision, and there is no such thing as raw data. Every format you encounter is highly structured mathematics.